Exponents. What are exponents? Exponents are basically numbers that are multiplied by themselves a certain number of times. Now, that certain number of times depends on the exponent, okay? So I have a couple of examples here. I have, the first one says 2 squared, 2 cubed, or, and I would probably say this one, 2 to the 4th power, okay? You could say that with these ones too, 2 to the 3rd power, 2 to the 2nd power, but these ones do have their other names, squared and cubed. Anyway, when my students see this for the first time, I don't even explain it. I just say, try and do what comes natural. Try to see if you can get the answer without me telling you. And their first intuition typically is to multiply like the 2 times the 4, and they get 8, or 2 times the 3, they get 6. And I do that just so they can get it wrong. I'm kind of mean like that. But that's not how we do it. Remember what I said. It's a number multiplied by itself a certain number of times. Okay, so let's talk about the parts of what an exponent looks like. What the parts are. Okay, so the number that's bigger, or the one that's written bigger, it's called the base. All right, bigger number is called the base. The small number, the little subscript number that's up above in the corner to the side of the number here, the small one, that's the exponent, or we sometimes call that the power. Okay. Now, what we never do, what my students try to do the first time they see it, is we never multiply the base times the power, or the base times the exponent. We will only multiply the base times the base times the base times the base, the certain number of times that the exponent tells us to. Okay? So it's base times base always, never base times exponent. Okay, so if we look at these, when I do these, the first thing that I ask myself is, what's my base, first of all, right? And that's going to be 2 for all of these. So, okay, our base is 2. Then I ask myself, how many times should I write that down? Or how many times do I need to write down the base? And I look to the exponent for that answer. And then the first one, it's 2 times. So I'll write down my base 2 times. All right? And once I have them written down, then I just multiply them together. 2 times 2 is 4. So that's it. It's kind of strange because, I'll give them this one the first time, and they go 2 times 2, and they get 4. I got the answer right. But remember, it's not this one times this one. It's the base times itself. Okay? All right, let's do the next one. 2 cubed. Well, I would ask myself, what's the base? It's 2. How many times do I write down the base? And it says to write down the base 3 times. So I'll do that. And after I write it down 3 times, then I just multiply those bases by themselves. So 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. Okay? And then over here we have 2 to the 4th power. And this would the same deal. I write down my base, which is 2, 4 times. And then we would multiply all those, and that will give us 16, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2, 16, okay? Now for this level of math that we're doing here, we're going to see you'll see a lot of those, I'm sure, okay? And another one that's relatively, well, before we do that, before I change it up a little bit on you, let's see if you can do one on your own. So here's an opportunity for you to pause the video and see if you can do it. So I'll give it to you right now. All right, pause the video, see if you can get this one. This one's 5 cubed. Go ahead and do it. Okay, how did it go? Did you get it? Well, let's see what it is. Let's see how it works. What's the base? The base is 5. So I write down my base, 5, 3 times, okay? Once it's written down 3 times, I'll multiply them together. 5 times 5 is 25. I can show that. And I'll bring down the other 5 that we have not used, and I'll bring down the multiplication that I have not used, okay? So now we have 25 times 5, and that's going to be 125. Okay, or we say 5 cubed is equal to 125. Okay, hopefully you got that one right. All right, so let me show you one that is also going to be very common at this level of math. So it's going to be one that looks like this. something like that, where the base has a negative sign. Okay, same thing. It's the same rule. We just, what's the base and how many times do I write it down? The base is not 3. The base is -3. It's important, okay? Be careful with that. So I'm going to write down my base, -3, 3 times. Okay? Now I got to multiply all those together. To show that multiplication, I'm going to use the parentheses to show that all these numbers are touching each other, right? And that would mean multiplication. Okay, so now we have to use the rules of multiplication and division of integers, the positive and negative numbers. In this case, remember that we're multiplying both signs and numbers. Okay, so let's start off with the sign, at least on the first multiplication here, on these two. So it's a negative times a negative. What's that give us? A positive, right? Same signs, multiplied or divided, it's positive. And then 3 times 3 is 9. Okay, there we go. I'll bring down the other one. Now the signs are different, they're opposite signs. So what happens here? Again, we're still multiplying, so positive times a negative is a negative. And then 9 times 3 is 27. And that would be your answer. -27. Okay, so just be aware of the signs. If it continued, then it would be -27 times another -3 and another -3. And it would be negative, and it would be changing back and forth between positive and negative. If we had a bigger exponent, that would tell us to multiply that more times. But anyway, this is a common one, okay? You're going to see some of these, so get used to some of these, all right? You can make up your own, okay? But just be aware that these are the kinds that you'll see more frequently than not. Now, there's a couple of more that I feel like I should say a little bit about, even though we really don't see too much of that at this level of math. And I want to show you because I don't want people saying that, you never taught us that, you never showed me that, right? So the first one, and this is very infrequent, you will rarely see these, but just so you have some resource showing you what they are and how they work. Basically, it's already there. Any number that has an exponent of 0 is going to be equal to 1. That's it. That's the rule. I don't want to get into all the details about why. All right, just put it in like more of a memory thing, like a rule. Okay. So, like for example, 3 to the power of 0, or 4 to the power of 0, 5 to the power of 0, 1,000,000 to the power of 0, whatever it is, it's going to be positive 1, just a 1. Okay. That's it. That's one you'll probably never see, but I just wanted to at least show you in case you do run into something like that. And there's one more it is a frequent one, but not so much for us, but I do want to mention it a little bit, okay? So that would be a negative exponent. Now, the negative exponent is going to be solved the same way as a positive exponent. Pretty much. Okay, so let me put a regular one here, a regular positive exponent one. So we know that in this one, my base is the 2, this big 2 here, and I got to multiply this number by itself 2 times. So I'll go ahead and write it out. There's my multiplication. And we know that it's going to equal 4. So we're going to do the same thing with this one, okay? It's going to be the same thing. 2 times 2 is 4. However, we take that 4, or that answer, and we do this. There's my 4, right? And then I just put a 1 over it, like that. Put it in a fraction form, and put the answer, the 2, like this part, like the 2 times 2 part, that answer will go in the denominator, and your numerator will always be 1. Always be 1, okay? So let me do another one so we have a couple of examples here, just so you can see how it works. What about this one? 3 to the power of -2. Again, this one with the positive 2 would be 3 times 3, right? 2 times my base. So that gives us 9. The top one, this one over here, is going to be the same thing. It's not going to change. It's going to be 9. However, we put it underneath what? A 1. Okay? And that's how that works. Okay, one more, and And we'll call it a day with this. Let's put that first, and then we put up the one you guys did by yourselves, right? Let's do this one. Now we know that 5 cubed with the positive 3, positive exponent, was 125. So this is going to be the same thing. It's going to be that 125, but we put that where? How do we show that? How do we write it down when the exponent's negative? We would just put that 125 in the denominator and then throw a little 1 on top. Okay? So basically that's it. That's pretty much the level of exponents that I'm going to get into right now. Now the exponents that have your base as a positive or negative, those are the most frequent ones that you're going to see. It's more rare to see the ones with an exponent that has a negative sign. But if you do see one, at least you know to put a 1 on top of it. Okay? So good luck. Keep practice and practice and practice and practice.